big research team. I'm not going to go through this. I just want to make it clear that I am the front man for a whole bunch of folks. The only thing I'd say, not everybody was working, especially that middle group, were working on the project at the same time. Most of them worked for 4 or 5 years and then got jobs and graduated and so on. But you understand, a lot of people worked very hard for a long time on this. Here's what we ended up with, in a nutshell, the current iteration of the theory of action. So in the middle, goals and vision. Goals means student learning goals. We put that at the center because what this is ultimately about is students' mathematical learning. And hand-wavily, we can talk about problem-solving, communication. This would be, I think, relatively well aligned with the sort of conceptually oriented goals that Kuno spoke about yesterday morning. Against that background, then vision refers to what's the vision of high-quality instruction? What counts as high-quality instruction? Where that has to be specific to those goals. What is the research base on that linkage? If we're aiming for those sort of goals, what should instruction look like? And I would say there's, at least in the US context for our goals, which have been stable for a while, there's a reasonably solid research base there. Now, moving out to the orange segment, instructional materials. Instructional materials that should be aligned with those learning goals and should support teachers in enacting the envisioned type of instruction. And as I understand, at least the paper, Kuno's paper circulated ahead of the conference, I saw it as focusing particularly on the relation between student learning goals, high quality, what counts as high quality instruction, and instructional materials, looking at to what extent those were in alignment and where there was a gap. And assessments just means it can include, obviously, formative assessments to inform the ongoing improvement of instruction. At the top there, we take the view, not take the view, there's very solid evidence that at least in the US, the envisioned forms of instruction involve very significant learning for most teachers. Clearly, even if they're outstanding instructional materials, just handing those over isn't going to do the job. There has to be ongoing sustained support for teachers' learning. And we came to see great value in thinking of a system of supports for teacher learning, that top segment. And I'll say something about that in a few minutes. I want to highlight the green part, supplemental supports for currently struggling students. That was not on our scope at all when we began this work. It wasn't a district policy, yet every school we worked in one way or another, was providing such supports. One of the common types of supports was a second math class. And they were trying to identify kids who would struggle on the state test and provide a second math class. What went on in those classes, by and large, was not very palatable to many of us. It was focusing very much on the, quote, basics, directly teaching procedures, and so on. A graduate student of Tom Smith's, Rebecca Schmidt, did a retrospective analysis, a quantitative analysis, and found generally those classes were ineffective, but sometimes they were actually detrimental. Now this matters because those were actually pretty expensive. These are districts that are really having to pick their spots. If we invest in second math classes for current students, we can't do so and so. A lot of money is being wasted. We've done scans of the literature, and God help us, we can't find anything specific to what to do for kids who are currently struggling if we're aiming at rigorous goals. There apparently is no research. There's stacks of stuff in special education, right? But it's a very different set of learning goals. And so again, another gaping chasm, which we found shocking. That I think we've got this sort of disconnect between the worlds of research and the worlds of practice in terms of problems that are actually worth investigating. So that's the sort of background. The only other thing I'll say is this. Maybe one reason we haven't been investigating that is because in math ed we tend to think if we've got a commitment or a view of what counts as high quality instruction, everything's going to be hunky-dory. Well, it's not. We've come to the view that in any instruction regime, including those in which we see great value, there are going to be kids who are not being served well. And so it's wise to plan ahead of time for that eventuality. And it's almost like if we investigate this issue, it's an admission of failure rather than a wise move that's at the service of kids. What I'm going to do is focus on a couple of parts of this. I want to focus first on the center, particularly relations between various types of teacher knowledge and perspectives and their practices. And then I'm going to focus on the top bit, the teacher learning subsystem, okay? So we have all these videos, got them coded each summer. The assessment we used, we didn't develop it. It's a big job to develop such a thing. It was called the Instructional Quality Assessment, developed by folks at the University of Pittsburgh. And here's the basic logic of it. First of all, look at the tasks the teacher was using in the lesson, just as they are on paper, not as implemented, and have a scheme for coding the level of rigor. Then look at the implementation. So here's what it looks, here's just a rough view of the coding scheme, just for level of rigor. And again, understand, we picked this when we started in 2006. This, in our view, was the then best available. So we've got at the bottom, memorizing and reproducing facts. That's actually not so common. Using specific procedures. This would be from Kuno's paper, Phil Darrow. This would be his view of teachers asking, what do I need to do to teach kids to solve this problem correctly? Teaching very specific. That was by far the most common, well over 50%, sometimes 2/3 of teachers. Even when they used rigorous tasks, and many did because of the textbooks, they would then teach procedures. And then the big shift is for teaching procedures with connections. That means it would include investigations to understand why particular methods worked conceptually. So kids could give conceptual, if it was arithmetic, they could give arithmetical explanations in terms of quantities for what was going on, and so on and so forth, up to genuine mathematics at the top there. The big shift, we came to see it, is between a 2 and a 3, and it's also quite a hill to get over, okay? And so that was on paper. Look at the task as implemented, what the kids are actually working on. So in a lot of the coding, it would be, the task might be a 4 or a 3, but the task the kids actually worked on after the teacher had introduced it was a 2, would be typical. And then there were a bunch of rubrics for the whole class discussion, focusing on various aspects like the extent to which kids were expected to explain their reasoning, kids making connections between solutions, teachers making connections, and so on and so forth. So that was the coding scheme. Also, the mathematical knowledge for teaching test, assessment, multiple choice. We also had to develop, and we had no intention of getting in the measurement or the measure developing game. But again, another thing, I sound like a great whiner, and I apologize today, but you become aware of how we really don't have good ways of assessing things that really matter. And so here's one thing we thought would really matter. What are folks' views of what high quality instruction looks like? Teachers, school leaders, district leaders, coaches. So in interviews, it proceeded like this. We'd say to them, suppose you can go into a classroom and you can stay as long as you want, the whole period. You can even go back a second time if you want. What would you look for to know if it was high quality instruction? And they sort of give a free response. And then our follow-up probes were specifically around the nature of the task, where again we're probing on language. If they say problem solving, we'd say, can you give us an example, because that's so ambiguous? Or conceptual, we'd say, well, what do you mean by conceptual? Can you give us an example, an illustration, or whatever? The nature of whole class discussions, the structure, who was doing the talking, as well as what they were talking about, and more specifically, the role of the teacher. They would say, well, the teacher should be a facilitator. What do you mean? What specifically might the teacher be doing in this situation or in that? And so that was then formally coded. Something similar?
What we were talking about yesterday.
Okay, so we coded this formally, and that became a measure that we could then use in quantitative analysis. And we called it VHQMI, views of students' views of high-quality math instruction. And we did use it in analysis. And what we found was that instruction as measured by IQA of teachers who had more sophisticated visions was more likely to improve. In other words, it's a leading indicator of improvement. Retrospectively, that makes sense to me, because it's very hard to develop practices if you don't have a clue what they look like, when you don't understand how they work or what the rationale is for them. It was in particular related to teachers selecting challenging, rigorous, or cognitively demanding tasks, and to maintaining the level of challenge throughout the lesson. So association is opposed to something cast iron. We developed a second measure, again interview-based right now, teachers' views of their students' current mathematical capabilities. So in the interviews, we'd ask them, have you got any kids who are currently struggling in math? Everybody does. Might laugh. So we'd ask them, who are these kids? Might be the poor kids, might be kids whose first language is English, it might be African-American males, whoever it is, fine. And we have two dimensions to this. The first is diagnostic. We'd ask them, why is it those kids are struggling? And we code it on a scale, unproductive. We would code as unproductive if they would say, attribute it to something inherent about the kids don't care, the kids are lazy, their families, parents don't care, they're working 3 jobs, they haven't got time to know about what their kids are doing, or the communities. And we say unproductive because they locate the source of the problem in something apart from the school, something apart from education they can't do anything about. At the other end, as productive would be if they would locate the source of the kid's challenge in terms of relation between the student and instruction. They might talk about prior instruction, they might talk about their own challenges this year, or whatever. So that's the diagnostic. And then the prognostic aspect is we'd ask them, and what are you doing to support your currently struggling students? Unproductive would be lowering the level of rigor by proceduralizing a task, skipping the more challenging aspects. And we view that as unproductive and also inequitable, because it's saying that one bunch of kids are not capable and not fit to engage in the more challenging mathematics, whereas these other kids are. We would code as productive if they provided those kids with additional supports. If the first language isn't English, and these are quite wordy, they have strategies for supporting the kids in understanding particular key terms, whether they partner them up with another kid, or they actually have discussions of these in the whole class ahead of time, that sort of thing. And again, this is formally coded so we could use in a quantitative analysis. We found, at least in our districts, that less than 20% of the teachers attributed students' difficulties to instructional schooling. This is bad news, right? Almost 30 attributed it solely to deficits, inherent deficits in students, their families, or their communities, and less than 20% describe making productive adjustments to instruction. Now, why does this matter? Because teachers with productive views of their students' current mathematical capabilities are more likely to maintain the level of challenge of tasks throughout a lesson, and they're likely to conduct higher quality whole class discussions, in particular where they press kids to explain and justify their reasoning. And sadly, there's also a nasty little interaction here with race, ethnicity, and linguistic composition of the class. What this means is, if there's maybe 50% of kids of color or whose first language isn't English, this relation is relatively weak, but increases as that proportion increases up to when it's above 90%, and the relation is pretty strong. So I would interpret that as an instance of racial and ethnic stereotyping, where teachers, many of whom are white, are making assumptions about kids' capabilities solely on the basis of race and ethnicity. And I would just stress these relations held even when we were controlling for teachers' mathematical knowledge for teaching and their visions of high quality instruction. So we think these matter. And there's one last thing. Former student of mine, Charlotte Sharp, was interested in why is it some teachers' quality of their instruction improves over time, others is flat or even declines over time. Why is that? So she pulled out, and we agreed and got a bunch of cases, and I think 16 altogether, that she analysed in detail of teachers in the same school. Some went up, some went down, and so forth. What came out of that is even when high quality supports, like a very strong coach who wants to work with a teacher, is available, was not successful unless the teacher had both sophisticated vision of high quality math instruction and a productive view of their students' math capabilities. I think that makes sense in retrospect. Again, it's tough if teachers don't have a view of high quality instruction. It's very tough to aim for that or know you want to develop it. But we also had teachers who would say, and they would give us an explanation of high quality instruction. And they'd say, yeah, that's good for those kids, but my kids can't do that. My kids aren't capable. In other words, there was a real blockage there. What this says to us is for professional development or whatever we want to do to support teachers' learning, just providing high quality support isn't going to do it, unless those supports also focus particularly on teachers' views of students' current mathematical capabilities at the beginning. More specifically, we are not in any way downplaying the importance of MKT, mathematical knowledge for teaching, but it's not the only game in town. I say that because when we work with our district leaders, they would always say, well, our teachers, wow, their mathematical knowledge for teaching is not strong enough. They're probably right. They were right in 3, but not the 4th district. But that was the only thing they ever mentioned. They never looked at any of this other stuff. And we've tried to indicate it's important because we have to elicit, foster, nurture, fan, whatever metaphor you want to use, development of teachers' will and agency, their reason and motivation to want to put in the effort, and it's a hell of a lot of effort, to improve the quality of their teaching. That's not going to happen unless we address their visions of high quality instruction, their views of students' current mathematical capabilities. And we think we've got pretty solid evidence that's the case, and that together these influence the level of challenge of tasks teachers select, the extent to which they maintain that level of challenge, and the extent to which they elicit and build on their students' thinking. So, Pete, we have a decision to make. I can stop here and we can have questions, or I could go on and talk a bit about our findings relating to the teacher learning subsystem. Okay, if you would like. So, I'm going to start by focusing on pull-out professional development. And I say this because at least in the US we have this sort of reflex action. Teachers need support. Let's provide PD. Yeah. The only thing about pull-out professional development, not our own work, there's a lot of research around PD, and it's not one-off workshops. We know the characteristics of high quality. So it's organized very close to practice, organized around the instructional materials teachers are using. It's sustained over time. There are multiple sessions that build on each other, maybe across a whole school year. Same group of teachers attend and so forth. Focuses on specific practices, and I'm not going to go through the whole lot. This will take a while. But there are certainly, this is non-trivial to offer. Let's be clear about that to start with, what high-quality professional development looks like. But what did we find, or drawing on other people's literature? If the goal is to support teachers to just make adjustments to their current instruction, to influence what is taught and when it is taught, which topics, just 1 or 2 PD sessions, workshops, would be enough. We could see that's pretty straightforward. On the other hand, mainly from our own, but other people's work as well, if the goal is to support teachers to reorganize their current practices, and that's what's involved in the proposals in play in the US right now. In other words, you're not just dickering around with what's taught and when it's taught, but how it's taught. Pull-out professional development by itself is often not sufficient, even when it's of high quality. So this is not the best news. There's a growing body of evidence, Hilda Borko and others' work as well, we're in touch with. And that's part of the reason for why we came to think of the various types of support our districts offered as should be organized into a system. Typically what happened was the pull-out professional development was very variable. Oftentimes it wasn't math specific. Oftentimes it wasn't specific to what teachers were working on in their practice right now, and so on and so forth. Teacher collaborative time, nearly all our districts did that at one point or another. Most part, and it was not productive, and we'll get to why that was in a minute. There was no particular agenda. The idea of you just put math teachers together and wonderful things will happen. We would have predicted it would be false. We wanted to be wrong. Sadly, we weren't wrong. And then for coaching, they all implemented coaching in one way or another on their own initiative. Typically, the coach would observe and then give the teacher feedback, often email a few quotes, not particularly effective. And so that leads to what should be going on. And we also noticed, by the way, they'd have these, some of them were doing all 3 at once, and they were not in any way coordinated. So teachers were supposed to be learning 3 different things simultaneously. So I want to start with coaching and then build out quickly to the other 2, if that makes sense. So the rationale for coaching, why bother, is a strong conceptual rationale from a lot of isms, including sociocultural theory and so on. Coaches ideally are folks who have already developed relatively sophisticated instructional practices, and as Vygotsky would put it, can be more accomplished others who can support less accomplished colleagues. I would also point out the literature on professional learning, not just in education, other professions, emphasizes the absolutely critical role of engaging in activities close to practice with somebody who's already pretty accomplished. One way or another, there's no way around it. And we look at coaches both when they're working one-on-one with teachers in their classrooms and when they're working with groups of teachers in teacher collaborative meetings. So when we began this, there was really no literature on what sorts of activities coaches should engage teachers in an evidence-based way. We took a view that this was about supporting teachers' learning, therefore we need to focus on teacher learning opportunities when making those judgments. At the time, that was a very alien and strange way to think about it. The literature has come on in the interim. So we developed some criteria, and we also reviewed the literature for any empirical evidence of particular types of activity. And this is what came out of that. When we look at working one-on-one with teachers in their classrooms, types of activities that can be productive include modeling, but we also wanted to think for what purpose. Modeling is a coach might go into a teacher's classroom and teach the students while the teacher observes. We could see this as valuable in supporting teachers' development of a vision of what a high-quality enactment of specific practices looks like, how to introduce or launch challenging tasks so that all students can begin to work productively on those tasks, but without giving the math away, without demonstrating procedures. Also, could support teachers' development of more productive use of their students' current mathematical capabilities. The way we came to think about that is teachers, when they say my kids can't do it, are in a way right. But the tragedy is this: they see those students, but the only time they see them is in the context of their current instruction. And in that context, the kids maybe can't do much. Maybe they're not interested and motivated, and they overgeneralize to that view of the student is something inherent about the student. And we've seen cases where an accomplished coach will go in and model, and you see the same students can suddenly have capabilities that the teacher did not suspect if they are provided with the appropriate support.